PHP provides several interfaces for using MySQL. The original interface was simply called MySQL. It was modeled closely after MySQL's basic C language interface and is still widely used, especially by programmers with a background in C. The MySQLi interface was introduced in PHP version 5.0. It's designed for newer versions of the MySQL database engine. It's also object-oriented, and it's being actively developed. If you're doing new development using modern versions of MySQL and PHP, I strongly recommend that you use MySQLi instead of MySQL. The PDO interface is a newer, more modern, object-oriented, multi-platform interface that supports more than just MySQL, but supports other database engines as well. This is the interface that I prefer and the interface that I do all of my new development when I'm using MySQL with PHP. As we talk about the MySQL interface in PHP, I want to show you some code and use this code as an example to explain how it works. And this code is in a program called CRUD, which does the create, read, update, delete functions in a database. And it's the most basic kind of a database program, and I created it for an example so that we can illustrate these basic functions. So we're going to go ahead and install CRUD first so you can see how it works and so that you can use it and test it as you play with the code. So this is the XAMPP directory in the local C drive. I'm going to double click there and put it in htdocs and just copy the program over. This is exactly how we did the SID installation, and for those of you on a Mac, you can just do exactly what you did with SID. I'm going to go into the CRUD directory and I'm going to edit the CRUD program and make sure we put in our web password .pass, just like we did with SID. And with CRUD, there's actually a second copy, CRUD-MySQLi, which is for the MySQLi interface. So I right-click on it, click on Edit with Notepad++, and put in the password. Now we can go ahead and run it in the web browser. And it's in the same place. It's called CRUD and CRUD.php. So this is the CRUD application. It uses the album database, and you can see it's got a list of albums, and inside each of these albums there is a list of tracks. And so this is basically how it works. You can add a new album. An album must have an artist, so new artist. And you can add tracks. Track number 1, this is track 1, and it's in 12 minutes and 32 seconds. And a track 2, this is another track. It's in 3 minutes and 16 seconds, and so on. And say done, and there it is, new album, new artist, etc. There it is. You can delete tracks. Has a little confirmation page. You can delete whole albums. You see that this deletes the album and all of its tracks. And what we're going to do is we're going to look at the code that makes all of this work and see how that code is written and how it interfaces with the MySQL database. So let's take a look under the hood in the CRUD application. This is a special version of CRUD that uses the MySQLi interface. The version of CRUD as I originally wrote it uses the PDO interface, and that's the interface that I prefer, and that's the version that I will maintain. I created this separate version to demonstrate how the MySQLi interface works. And so this is the MySQLi version of CRUD. This is the line here where the database is initialized. This is where we set up the connection to MySQL. And so it creates a MySQLi object. We're using the object interface of MySQLi. MySQLi has both an object interface and a procedural interface, or a non-object interface. We're using the object interface to MySQLi. The code looks a little bit different, but it works pretty much the same. And if you can follow along with this, if you see code that's procedural using MySQLi, it should be obvious what it does. So this sets up the MySQL connection. It provides the host name, the username, the password, and the database. The host name is a variable, and that's set up here, and it's set to be localhost. It's set to the literal value localhost because CRUD is not designed for a production environment. It's only designed for a personal testing environment, and so we really only want to run it on localhost. We're not going to run it on a remote host ever. It sets up the database is also set up to album here. And the username and the password and the database are all set up at the top of the program, and here they are. And those are constants, they're not variables. So a couple of things to note about the MySQLi interface here. One is that MySQLi does not support persistent connections with the default MySQL driver. Persistent connections are very useful in a web environment. What a persistent connection is, it's a connection between the web server and the database server that stays active and stays alive and does not need to be created every time there's a web connection. Without persistent connections, every time somebody brings up a web page, even if it's the same user in the same session, from page to page, there's a whole new instance of the web server and there's a whole new instance of the program. And that new instance actually has to create its own connection to the database server. And this takes time and resources. Persistent connections reuse the connections so they don't have to be set up every time. And that every time can be a lot, especially in a busy web environment. So I consider persistent connections vital. And they're not supported by MySQLi in the default configuration. And there's actually very, very few configurations where it will work. Another thing to keep in mind is that there's a bug in versions of MySQLi before PHP version 5.3 that do not allow the use of the connect error function. And so instead we have to do our errors this way. And so this is just the buggy nature of the code. MySQLi is still being actively supported and developed, but not very actively. The developers are really paying more of attention to PDO, and so that's the more reliable code. So we have to do a few little things like this to work around some of the problems in MySQLi. So this is the code that sets up the connection. It's actually very simple. You create an object using the standard new object syntax in MySQL, and it puts the object in this variable called DBH. It's called DBH for traditional reasons. That's just the traditional name of a database handle. And so I like to use traditional names for things because it's easier to read the code later when I come back to it and I haven't seen it for a while. I can know pretty much instantly what it is that it's doing. So this is how the connection is set up. If the connection setup fails, it calls the error function, which is an internal function that exists in the CRUD application for displaying errors in red on the screen. And it uses this @ sign to prevent PHP from throwing an error to the screen, and it allows us to use our own error reporting mechanism. So that's pretty much it. That's the initialization code for setting up the database connection using MySQLi in PHP. This is the function update album SQL, and this is where the SQL lives for updating the album table in the album database for the CRUD application. And one of the significances of this piece of code is that it introduces us to prepared statements and bound parameters. So we're going to talk a little bit about that here and talk about how this works. So here's the query, and you can see it's standard SQL, update album, set title, artist, label, etc. You'll notice that the values that are being set to these column names are question marks. And those question marks correspond to this bind parameter function call. And each of these variables, title, artist, label, released, and ID, which is hiding off to the side there, these question marks get replaced with these values. And the bind parameter function and the MySQL drivers actually go to the trouble of properly quoting these for inclusion in the SQL so that you don't have to worry about that. And that's a big convenience. And it also prevents errors and makes it work more reliably at runtime to have the system doing that rather than you having to do that manually in the code. And so that's what prepared statements are, and that's why they exist. They also allow some other efficiencies. There are some cases where you might be able to prepare a statement and then in a loop bind different parameters to the same statement without having to prepare the statement over and over, and that can create some efficiencies. But the major advantage here is in the reliability and scalability of having these parameters automatically bound to the placeholders in the code. So I like prepared statements. One of the things that disappointed me about the MySQLi interface is that you cannot use prepared statements in all of the different contexts. So that's one of the reasons why I chose PDO over MySQLi for my work. But this is how it works in MySQLi, and it's very useful. You'll notice in the bind parameter, the first argument to the bind parameter function specifies which types these different variables are. So we have SSSSI, which means string, 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 integer. And that tells it how to do the quoting. So there you have it. That's how the bound parameters and the prepared statements work in MySQLi in PHP. So let's take a look at how you execute a query and fetch the results. This is getAlbumsSQL, and it's a simple function that just assigns a query, select everything from the album, order by title, and executes that query and returns a handle to the results. It does not actually return the results, and this is an important distinction. Query result handle, QRH stands for query result handle, there in the comments, is a handle to the executed query, and it allows you to fetch the results one by one. The importance of this is that if your table is very, very large and you don't know how many albums somebody might have in their albums database, there may be more data than would even fit in memory in the computer. And if you go and load up a variable with more data than will fit in memory, well, something's going to give, and it could create security problems, it could create stack overflows, it could crash your computer. So instead what we do here is we perform this query, and it gets all set up, and then the results are simply grabbed one by one off of the disk. And that happens up here in the list albums function. It calls getAlbumsSQL, so it gets the query result handle. And then down here, it grabs the first row, and that way it can test. If there is no first row, then we know that there's no albums in the database. And otherwise, we eventually get down here, and we set a row count, and we go ahead and build the results, album results row. That's a function that builds the HTML for the results from the row. And it increments the count, and then goes ahead and fetches more using this fetch associative function. The fetch associative function is great because it assigns an associative array to the result, and that associative array has all of the column names in the keys. So that's really, really useful. So this is how you do a query and get the results. You don't want to call some fetch all function that's going to load up your memory with some unknown amount of data. That way lies tragedy. Instead, what you want to do is be smart about it, execute the query, and then fetch the results one by one so that you can deal with them in bite-sized chunks that'll fit in memory one at a time. And this is how that's done in MySQLi in PHP. So this is how we insert a row into the database. This is insert album SQL. This is for creating a new album record in the database. Here's our query, insert into album. And we've got title, artist, label, released, and the values are replacement parameters that are given in this bind parameter function. So what we have here is a prepared statement. Now the interesting thing is that this particular table has an auto increment ID field. So you notice that we don't insert an ID number. The ID number is automatically generated. And yet, when we're done with this function, we want to be able to pass the ID number back so that it can be used in other contexts, because that's important. That's how we join our tables together. So we need to keep track of that. So there's a special function in MySQL called insertID that returns the last created auto increment ID. And so this generates an auto increment ID. MySQL keeps track of it, and it allows us to grab it here and return it as the return value of this function.